Okay, we're going to start chapter 7.1, which is talking about solving systems of equations. And we're actually going to be introducing matrices. So we're actually solving systems of equations using matrices. Okay, now what is a matrix? A matrix is a rectangular array of numbers with brackets. Okay, so it's just an arrangement of numbers. So here I've kind of have some brackets, and we'll put some numbers in there. Okay, and so I've got this arrangement of numbers inside of brackets, and a matrix is used to put data in compact places. So each matrix has what we call an order, and that's kind of like the size of the matrix. Okay, so we'll say size, and it is rows by columns. All right, so this one has, these are the rows, so 1, 2, 3 rows. So it is a 3 by, and it has 1, 2, 3, 4 columns. So it's a 3 by 4 matrix. Okay, now every number or every item in this matrix is called an element. Okay, so elements are items that make up a matrix. Okay, and each element has a specific address or location. Okay, so if we look at a couple elements here, let's say we want to look at number 2 here. Okay, it has an address, and it also goes by rows and columns, but it also uses the matrix identifier. So if I look at number 2, that would be M1, meaning it is in the first row, 2, second column. Okay, and we could look at M3, 3. So that would be the matrix M, third row, 1, 2, 3, third column, 1, 2, 3. So we're talking about that element right there. We also have what's called an augmented matrix, and an augmented matrix looks like this. Okay. Notice I've got this extra identifier here, and that just denotes an equal sign. And there are a couple properties that we want to know about an augmented matrix, and they are that each row represents an equation. Okay, like in a system, it would be 2 equations. Each column, okay, represents a different variable. So these might be x's, these might be y's, and these would be your constants, which are on the other side of your equal sign. And notice I've got a 0 here, so in this equation we would not have a y value. So if this is x, this is y, this would really be the system x plus 5y equals 3, and 3x equals -1. That's how we would write it out. Okay, so we have some row operations that we can do with these augmented matrices. So the first thing, we can interchange rows. Okay, so I can flip rows up and down, left, right. So let me just put okay. So I could flip these rows So this row here could become the first row and so forth. And we use some sentences here to denote that. So I might interchange row 1, might interchange with row 2. And we would just put it with a double arrow. The next thing we could do is we could multiply by a non-zero number. Okay, so I could take, if I had a row 3, I could take 3 times row 3 and put it back where row 3 is. Okay, so I'm going to take the row 3 out, I'm going to multiply it by 3, and I'm going to put it right back. And the last thing we can do is add and subtract. We can add and subtract rows. So I can also use the multiplier in that same step. So I could take 2 row 3 minus row 2 and put it back into row 3. Okay. You can actually put it in either row 3 or row 2. Okay, now this is row 1, like I said, and this would be row 2. Okay, so I can multiply them, I can switch them, I can add them together. I can do all sorts of stuff. So we have two forms that we want to get these augmented matrices in. Okay, and the first form that we might want to get them in is called the row echelon form. Okay, it is often noted REF for row echelon form. And the first thing with row echelon form is that rows with all zeros are at the bottom. So all 0 rows are at the bottom. Okay. The next thing is each non-zero row starts with a 1. Okay, so if you read it from left to right, you can have zeros up to your first number, and then that has to be a 1. So first non-zero number in row is a 1. Okay, and the third thing is the leading ones go from top left to bottom right. Okay. They go from top left to bottom right. And I'll show you an example here in just a little bit. Now, to be reduced row echelon form, which is our REF, okay, we have all 3 of these plus one more item. And that is that after your leading one, everything above and below that leading one is a 0. Okay. So on this one just kind of says that anything below your leading one is a 0. Okay, this says above and below needs to be a 0. Okay, so we could look at an example here. Right here, I've got these ones on my 0 row. I've got my 1 with zeros under it, 1 with zeros under it. So I've kind of got this triangle down here of zeros. Now down here, notice I have 2 different triangles of zeros. I've got all diagonal ones. And so these augmented matrices, the way we're going to use them, it'll just be a fancy way of doing elimination. It'll be a nice organized method for us to do the elimination method. So steps for Gaussian elimination. Okay, so we're going to write as augmented matrix. Okay, we're going to use row operations to get REF. Then we're going to, once we have REF, we're going to rewrite into equations. And the last step is we're going to use these equations in step 3 and back substitute to solve. Okay, so use that substitution and we'll solve these out. Now, steps for Gauss-Jordan elimination is very similar to these. Okay, but instead of getting REF, now we want our REF. Okay, so steps for Gauss-Jordan elimination is to write as an augmented matrix. Okay, then you're going to use row operations to solve to get it into RREF. Okay, and then step 3 is you're going to write it as equations, which will be your solution. Okay, so with this one, we don't have to have that back substitution at all. So steps for doing on calculator. Well, we've got our calculator here. We've got some buttons. And because this is brand new, you can do it on the calculator, but we are not there yet. So I don't want you to be doing this on the calculator, even though your calculator can do it. We need to make sure that we understand the basics of how to do this by hand before we do it on the calculator. Okay, so that is actually the end of the first part of the video. Okay, so here are your chapter 7.1 questions. Okay, what is a matrix? What is an augmented matrix? What row operations can I do on an augmented matrix? And what's the difference between REF and RREF? You might want to go ahead and put the steps down for REF and RREF just to make sure you have it. Here are some suggested problems that I want to go ahead and give to you. 105 is your challenge problem. Just might show up on a bonus on the test or something like that. So if you would like, you can go ahead and stop here. I'll continue on with more examples on how to do this kind of stuff. Be sure to like and subscribe below. Leave a comment if you would like. Okay, let's continue on with some examples of this chapter 7.1. Okay, so what is the order of these matrices? Remember, order goes rows. How many rows by how many columns? So this has 1, 2 rows and 1, 2, 3 columns. So that's a 2 by 3 matrix. This next one has 1, 2, 3 rows, and it has 1, 2 columns. So it's a 3 by 2. Notice they're kind of switched around a little bit. Okay, this one has a 3 rows, 1, 2, 3, and 1, 2, 3, 4 columns. So that's a 3 by 4. Okay, so write as an augmented matrix. We're going to get lots of practice with this. So what we want to do is we're going to take all of our coefficients and we want to line up all our x's, y's, and z's. Okay, so this first row here will be the first equation. So it'll be 3x's, negative 2y's, 4z's, and an answer of 5. The next one doesn't have any x's, so it's a 0. It has 1y, negative 3z's, and negative 2 as the answer. The next one has 7 x's. It doesn't have any y's, has negative 1 z's, and 1 as the answer. So there's my augmented matrix that I'm now going to do some operations with. Okay, now how do I go about doing operations with this? We'll get some practice right here with these. So here's my augmented matrix. We'll call this matrix M. And the first operation I want to do is interchange row 1 and 2. Okay, so here's row 1, here's row 2, and I'm just going to switch them. So this first row now becomes 3, -1, 2, 3. The second row was the first row up there. And the third row, nothing happened to it. Okay. So simple interchange. Okay, this one we're going to take 2 times row 3, and we're going to interchange, and we're going to put it right back where row 3 is. So I'm going back to this original matrix up here. So row 1 isn't changing at all. Row 2 is not changing at all. And row 3, we're simply multiplying by 2. Okay, so everything in there should be doubled. Okay, and our last one here is a little bit complicated. What we're going to do is we're going to take row 1 and we're going to subtract 2 times row 2. Okay, so the element right above it, we're going to multiply and subtract. And we're going to put it back into row 1. Okay. So I like to draw out or go ahead and rewrite the rows that aren't doing anything. They're not changing. So I notice that row 2 won't be changing. So 3, -1, 2, 3. Row 1 is definitely changing, and row 3, I'm not even dealing with that right now. Okay, so we're going to take row 1, the row 1 element, which is -1, and we're going to subtract 2 times the element in row 2, which is a 3. So we have -1 minus 6. -1 minus 6 is -7. And we do this throughout all the columns. So we have our row 1 element minus double our row 2 element. Okay, so you have 0 minus 2 times -1, which is 2. And then you have your row 1 element minus double your row 2 element. So that's -1 minus 4, which is -3. And then you still have to do the answer as well. Okay, you got to do this to every column. So we have row 1 minus double row 2. So then you have -2 minus 6, which is -8. Okay, and you can add rows. You can do whatever you want with these rows. Just make sure you stay organized and do the right calculation to all the numbers. Okay, let's determine if these are REF, or neither. Okay, now remember, this is row echelon form. Okay, so your 0 rows at the bottom, you have your leading ones going in the diagonal. Okay, so if we look at this first one here, I don't have any all 0 rows, so that's good. Okay, I've got a leading one, and the rest can be numbers. Now here, this is not a 1. Remember, my first non-zero number has to be a 1. So this is not our REF, therefore it can't be our REF, so it is none. Okay, so I've got a leading one, zeros below it. Okay, I go to the next row, I get a 0, there's a 1, 0 below it. Okay, so the numbers after that don't really matter. And then I got a 1 here, and it's at the bottom, so that's okay. So this is REF. Now we check for our REF. Remember, our REF had everything REF had, except your leading one had zeros above it also. So this one's got nothing above it. This one has a 3 above it, so that means it cannot be an REF. Okay, so this one, we've got a leading one in the numbers, zeros below. I've got a leading one no zero below it, numbers, that's okay. But here's the problem here is that this one needs to be on the other side of this one. They can't go in this order. Remember, they're supposed to go diagonal down across. So this is actually neither. However, with row operations, all I would need to do is interchange these two rows. Okay, we would take row 3 and interchange with row 2. And then we'll notice that this matrix does become an REF matrix. Okay, so now we've got our diagonal ones, we've got numbers below it. So now it is an REF matrix. This one, we've got a 1, 0 under it. I go to the next spot, a 1, no zeros under it because it's the last one. So this is definitely REF. Okay, and my leading ones have to have ones below and above. So that's got zeros below and above, zeros below and above. Now these were not leading, so that's okay. We don't have to worry about them. And this one's actually RREF. Okay. Now it's important to know which one we want. That way we know when we're done with some of these problems. Okay, so now we're going to get into some of the actual problems here and solving them. So the first one we're going to do is solve using Gaussian elimination, which is REF. Okay, now sometimes these can take a while, so and they may take a lot of paper if you write kind of big, so make sure you're prepared for these. Okay, so the first thing I'm going to do is write as an augmented matrix. Okay, now once I have an augmented matrix, I'm going to want to use row operations to get it into REF mode or REF form. Okay, so I want a 1 up here in this spot. So in order to do that, I'm just going to interchange these rows. Okay, so now once I interchange the rows, I'll have a 1 up here. Oop, I forgot to interchange that 6. Okay, so now I have my 1 up here. Now, since this is a 1, this needs to be a 0. Okay, so since this is the row that needs to change, we're going to say row 2 minus double row 1. And we're going to put it right back in row 2. Okay, so I'm going to take this whole row, multiply it by 2, and then subtract it from this one. Okay, so row 2 is changing, but row 1 is going to stay the same. Okay, so I'm going to take row 2, which is 2, minus double this number, so that'd be 0. And you can mark this off to the side. You could say 2 minus 2 times 1, which is 0. Then you could say we go to the second column, 1 minus 2 times 3, which is negative 6. Sorry, negative 5. And then we will have 8 minus 2 times 6. Okay, so that's 8. That's a negative 8 right there. That's a negative 8. So this should be negative 20. Okay. So I got my 1, I got my 0 under it. Now this number right here needs to be a 1. So we're going to take this and we're going to multiply it or divide it by negative 5. So I'll take negative 1/5 times row 2, and we'll put it right back in row 2. So row 1 isn't changing. Row 2 is getting divided by -5, so that's a 1 and that's a 4. Okay, so now this is in REF form. I've got my diagonal 1s and my 0s in the lower left. So we will rewrite these as equations. So these are your x's, these are your y's, these are your constants. So I have x plus 3y equals 6, and I have y equals 4. So that gives me what y is, so we'll back substitute it into the equation above. C of x plus 12 equals 6, subtract 12, and you get x equals -6. So then you have your ordered pair, -6 comma 4, as your solution to the system. Okay, so these can be a little tricky. Just have to be really, really organized. Okay. All right, let's try another one here. So still Gaussian elimination. So we want it in REF. So we can do back substitution. Okay, so the first thing is an augmented matrix. Nope, that's a -1. So 8, 1, -2. Your solutions -1, -2, and 2. Okay, the first thing I want is I want a 1 up here. So we're just going to interchange these two rows. So we're going to take row 1, interchange it with row 2. So 1, -1, 1, -2, 2, 1, 8, -1. And the third row didn't do anything. Okay, so now that this is a 1, okay, we want these to become zeros. So row 2 needs to change, and I'm going to subtract double row 1. Okay, this second part will always be the row with your 1 in it, and we're going to put that in row 2. Okay, so let's do that. So row 1 isn't changing. Row 3 isn't changing. So I'll go ahead and write those down so I don't forget. Okay, so we're going to take row 2 minus double row 1. So row 2, which is 2, minus double row 1, which is 0. Row 2, which is 1, minus double row 1, which is 3. We're going to take 8 minus double 1. Okay, so that's 8 minus 2, which is 6. Then we have to do our answer. So that's -1 minus 2 times -2. So that's -1 plus 4, which is 3. Now we also have to get this to be a 0 also. So we're going to take row 3 minus 3 times row 1. We'll put that back in row 3. Okay, so we're changing row 3 here. So row 1 and 2 stay the same. Now, as we get good with this, we can combine some of these steps. Like later on, you might combine both of those steps. Okay, so I've got row 3. So that's 3 minus triple row 1, which is 0. We got -2 minus triple row 1. So that's -2 plus 3. So that's 1. We've got -2 minus triple row 1, which is 1. So that's -2 minus 3. So that's -5. And we have 2 minus triple row 1. So that's 2 plus 6, which is 8. Okay, so now I've got a 1 and zeros here. I need a 1 here. Now, if you look here, I can just take these and divide them by 3 to get my 1 there. So we'll take 1/3 row 2, and we'll put it back into row 2. So it's 1, -1, 1, -2, 0, 1, 2, 1, and 0, 1, -5, 8. So since this is my leading 1, this one below it has to be a 0. Well, since row 3 needs a change, we're going to subtract row 2. Okay, now you can't do row 1 because that's going to change this 0 over here. You have to do the one with your leading 1. And we're going to put that back in row 3. So row 1 stays the same. Row 2 stays the same. And row 3 is getting subtracted. Okay, so that's 0 minus 0, 1 minus 1, negative 5 minus 2, and 8 minus 1. Okay, so 1 with a 0 under it, so this leading term has to be a 1 here, but I can just divide by negative 7. So we'll take negative 1/7 times row 3, put it back into row 3. Okay, and we'll come kind of up here a little ways. So row 1 stays the same. Row 2 stays the same. And row 3 is getting divided by negative 7. So that's a 1 and negative 1. Okay, so now I have my REF form, my diagonal ones, my 0 triangles here, and these numbers are good. So we'll rewrite it as equations. So I have x minus y plus z equals negative 2. I have y plus 2z equals 1. And I have z equals negative 1. So there's z. So we'll take that and plug it in up there. We get y plus 2 times negative 1 equals 1. So it's y minus 2 equals 1. So y is 3. So we'll take that, plug it in along with the z into the top equation. So we have x minus 3 plus negative 1 equals negative 2. So it's x minus 3 minus 1 equals negative 2. X minus 4 equals negative 2. And x is 2. So we have our ordered triple. We have 2, 3, minus 1 as our ordered triple. Okay. Again, a lot of work. It can be really fast. I like it much better than trying to deal with the letters at the same time. All right, so this one's a little bit different. It's Gauss-Jordan elimination, which is our REF. Okay, this one's my favorite. Okay, and you'll see why at the very end. Okay, and on this one, I'm going to kind of try to combine some steps all at once. So the first step is write as an augmented matrix. Okay, you want a 1 in the top left, which we already have, which is good. Okay, the next thing is I want this row and this row to have zeros here. Okay, so row 2 needs to change. We're going to subtract 3 times row 1, put it back into 2. And I'm actually going to make this a 0 at the same time. So row 3 needs a change, and we're going to subtract double row 1 and put it back into row 3. Okay, so that's a lot going on right there. So row 1's not changing. Okay, so for this one, I'm gonna cover up this one for now. We're gonna take row 2, which is 3, minus 3 times row 1, which is 0. Oh. Then move to the next column. So 2 minus 3 times row 1. So that's 2 plus 3, which is 5. Next column. So negative 6 minus 3 times 2. So that's negative 6 minus 6. It's negative 12. And our answer, 1 minus 3 times row 1. So that's 1 plus 3, which is 4. Okay, so now we can move to the second operation we're going to do, which is row 3. So that's a 2 minus double row 1. Okay, so that's 0. Then we have 3 minus double row 1. So that's 2, that's 3 plus 2. Then we have 4 minus double row 1. So that's 4 minus 4, that's 0. And we have 8 minus double row 1. So that's 8 plus 2, which is 10. Okay. Now, I want a 1. So my first column's good. I got a 1 and zeros. Now here I want a 1 here and zeros above and below. Well, if we look here, okay, my 1s will go here and I'll have zeros in this lower and zeros in this upper. I kind of want this row in that second row, but I have to divide it by 5. So what we're going to do is we're going to take 1/5 of row 3 and we're going to interchange it with row 2. Okay, so we're going to flip spots and we're going to divide it. So row 1 isn't changing. Row 2 is actually going into row 3. And this row 2, we're going to divide by 5. Okay. Now I got to get 1s above and below it. Okay. So row 1 needs to change. And we're actually just going to add it to row 2. And we're going to put it back into row 1. Because if I add these two, that will give me a 0. And I want the 0 back right here. Row 3 has to change. And we're going to subtract 5 times row 2. And we're going to put it back into row 3. Okay, so a lot of work here. So our middle row is not changing at all. All right, so row 1, we're just adding to row 2. So that's 1 plus 0, that's 1. Negative 1 plus 1, that's 0. 2 plus 0 is 2. Negative 2 plus 2 is 1. Okay, so that wasn't bad. Row 3, so we're taking row 3 minus 5 times row 2. So that's 0 minus 0, that's 0. 5 minus 5 times 1 is 0. Negative 12 minus 5 times 0, that's still negative 12. We have 4 minus 5 times 2. So that's 4 minus 10, that's negative 6. So I got a 1, 0, 1, zeros above and below. So this right here needs to be a 1. So we got to divide it by negative 12. So that's negative 1/12. Row 3, back into row 3. Okay, and we're kind of running out of room here. So this row's good. This row is good. This row gets divided by negative 12. So that's a 1.5. Okay, but this row right here has to be, or this element has to be a 1. Or sorry, it has to be a 0. So if we come back up here, okay, row 1 has to change. And we're going to subtract double row 3, put it back into row 1. So row 3 is good. Row 2 is good. So row 1 minus double row 3. So that's 1 minus 0 is 1. 0 minus 0 is 0. 2 minus 2 is 0. And you have 1 minus what would be 1, which is 0. Okay. So now I have our REF. I got diagonal 1s, 0 in the lower, 0 in the upper triangle. So now I can go straight to my equation. So this one is x equals 0, y equals 2, okay, because 0x's, 1y, 0z's. This is z equals 1/2. Well, that's nice because I have no substitution, and there are my answers. So I have 0, 2, 1/2. And we are finished. Okay. We can do this with bigger examples. Okay, here's an example. I won't quite do this one, but we'll set it up in the augmented matrix. Don't let the number of elements in the augmented matrix mess you up, because this could really only take a couple steps. So this one has 0x1s, 3x2s, 0x3s, negative 2x4, and 4. This has 2, 0, negative 3, 0, negative 1. And notice these are flip-flops. So this is a 2, 0, 0, 4, minus 6. Okay, so notice you already got you've got your 1 up here. So these have to become zeros. Then this will have to become a 1 with that being 0. So you have a lot of zeros already in here, which is really going to help you out. Okay, so I might leave you with that one to do. Okay, so I want to definitely go over these two. Okay, so solve, and I say solve using any way because it doesn't really matter. You'll get the same answer either way. So we'll put it as an augmented matrix. Okay, I've got my 1 in the top left here, so these two need to become zeros. So row 2 minus double row 1 back into row 2, and row 3 plus double row 1 back into row 3. Okay, so kind of do that over here. So row 1's fine. Okay, so this one minus double this one. So that's a 0. That's 1 minus 4, which is negative 3. That would be 2 minus negative 2, which is 4. That's 1 minus 6, be negative 7. Okay, then coming down here, we'll add them. So that's negative 2 plus 2, 0. That's negative 4 plus 4, that's 0. That's 2 times negative, 2 plus negative 2, that's 0. And this would be 5 plus 6, which is 11. Now notice here, in that last row, I have 0, 0, 0, 11. That's saying 0x plus 0y plus 0z equals 11. So that's saying 0 equals 11 somehow. Well, remember when we get that, that is no solution. Automatically, you can stop right there when you get something like that. We also talked about infinite solutions, so let's look at this one. Okay, we'll have our augmented matrix, putting zeros as placeholders. Oh, not a B, that's a 1. Okay, we've got our 1 up here. So these need to become zeros. Okay, so row 2 minus double row 1 back into row 2. And this is row 3 minus 3 times row 1 back into row 3. So row 1 is good. Okay, so that's 2 minus 2, 0. That's 1 minus 0 is 1. That's 4 minus 2 is 2. And that's 8 minus 6, which is 2. 3 minus 3 is 0. 1 minus 0 is 1. 5 minus 3 is 2. 11 minus 9 is 2. Now you might see here what's going to happen. Okay, notice these two are the exact same equation. Okay, so this is a 1. So I got a 1 and zeros. I got a 1. I need zeros above and below. So this has to be a 0. So row 3's got to change, and we're just going to subtract row 2, put it back into row 3. So 1 is good. 2 is good. That's a 2. And row 3, 3 minus 2. So row 3 minus row 2. So 0 minus 0 is 0. 1 minus 1 is 0. 2 minus 2 is 0. 2 minus 2 is still 0. So this bottom row is saying 0x plus 0y plus 0z equals 0. So 0 equals 0 means infinite solutions, okay? Now, when you get infinite solutions, okay, that still means we need our ordered triple, okay? We still need some ordered triple there, okay? But we still have equations. I've got x plus z equals 3. I have a y plus 2 equals 2. And this last one, okay, is kind of like the variable one we do. So we can say z equals a, or if you want to use z equals z, okay, it doesn't matter. So we'll put an a right here. Okay, so we got to take this one and solve it for y. So y equals negative 2a plus 2. So I went ahead and substitute the a in for z. And then we solve this one for x. So x equals negative a plus 3. Okay, or if you use the z, that could be negative z plus 3, negative 2z plus 2, and z. I'm okay with either one. It doesn't matter. You get the same solution no matter which one you put. It's all the same. Now, there are many application problems for this. This is just another infinite solution one here. If you want to take a look at that one, I'll do it real quick here. 2, 1, 1, 8. Now, we automatically know that this one has infinite solutions because there's only 2 equations, but I have 3 unknowns. Okay. So I already know in the end that z is going to equal z. Okay. I just got to figure out what x and y are. So the first thing I need to do is probably interchange these rows. So we'll do 1, 1, -1, -3, and 2, 1, 1, 8. You can actually do that from here to here if you would like. Okay. So this needs to become a 0. So we'll take row 2 minus double row 1, put it back into row 2. So row 1 is good for now. So that's 2 minus 2, which is 0. That's 1 minus 2, that's minus 1. That's 1 minus negative 2, so that's 3. And that's 8 plus 6, which is 14. Okay, so this needs to become a positive one. So all we have to do there is change the signs. Okay, so that's good. Now this here has to become a 0. Okay, so all I'm going to do is subtract the 2 rows. So row 1 has to change minus row 2, and that goes back into row 1. Okay, running out of room here. So row 2 is good. Okay, so that's 1. That's 1 minus 0. That's 1 minus 1 is 0. That's -1 minus -3, which is 2. That is -3 minus -14, which is 11. Okay, so now I'm good. I'm in RREF. I know z is z, so I have x plus 2z equals 11, and y minus 3z equals -14. Okay, so I solve each one of these for x and for y. So x is going to be -2z plus 11, so -2z plus 11, and y is going to be 3z minus 14, 3z minus 14. Okay, and there is your solution as an ordered triple, which is what we want. So application problems, I'm just going to help you set these up okay, which is usually the hardest part, just setting these up. So you go to Subway to get a sandwich for your lunches and dinners for the next week. Your goal is to eat 388 grams of protein and 4,900 calories. How many of each sandwich should you eat? Okay. Well, I've got 3 sandwiches: veggie, chicken, and ham. So XYZ, I want to know how much of each. Well, that's lunch and dinner for 1 week. Okay. A week is 7 days, 2 meals. That makes 14 meals. So my total number of sandwiches is 14. Okay. Now I need 388 grams of protein. If we look here, here's the protein. So I got 36x plus 20y plus 19z. That's going to equal 388. Okay. Then I've got 4,900 calories. Here's your calories. So I've got 350x plus 430y plus 290z equals 4,900. Okay. Now we could make these numbers a little bit easier. Maybe I divide this one by 100 and go from that route, or I just leave them the same, put them in my augmented matrix. And then I got 350, 430, 290, and 4,900. Okay. Then you'll probably want to do RREF on this one. Okay. Solving this out for X, Y, and Z. So if you try that on your own, you'll get X to be 7. Y to be 3, and Z, which is a ham sandwich, will be 4. Okay, try that out. If you have troubles, let me know. But I'll definitely work out this next one. Okay, so find an equation in the form. So we'll get a quadratic that fits the following ordered pairs. Okay, so these are my ordered pairs here, and I need them to fit this equation. So I'm going to have 1, 2, 3 different equations. So I have y. So in this case, 253 equals a x squared. So that's 1 squared is 1 plus bx, which is b, plus c. Okay, the next equation is 287 equals ax squared. So that's 25a plus 5b plus c. The next one is 431 equals ax squared. So that's 100a plus 10b plus c. Okay, so there are my equations. If I go ahead and put that in an augmented matrix, look like 1, 1, 1, 253, 25, 5, 1, 253, and this is 100, 10, and 1. Oh, this is 287, and this is 431. Okay, now we'll probably get some crazy numbers on this one. Okay, and that's all right. So again, these need to be 0 here. Okay, so row 1 needs to change. So row 2 needs to change, minus 25. Row 1, put it back into row 2. And row 3 needs to change, minus 100. Row 1 back into row 3. So when I do that, row 1 is fine. Okay, row 2 will become 0, negative 20, negative 24, Oh, and this is a big one, negative 6038. Okay, gonna probably want a calculator for doing this. Okay, and row 3, after I apply this rule, row 3 becomes 0, negative 90, negative 99, and negative 24869. Okay, so this row right here needs to become a 1 right here. So we'll take row 2 times negative 1 over 20, put it back into row 2. So 1, 1, 1, 253. 0, negative 90, negative 99, negative 24869. 0, 1, 6/5, 3019 over 10. Okay, so I got a 1 here. Now this one and this one have to become zeros. Okay, so row 1, let's work on this one being 0. So row 3 needs to change. And we'll take row 3 plus 90 row 2. And we'll put it back into row 3. So that's good. This one's good. This one will become 0, 0, 9, 2302. Okay, so I'll get a 1 here by just dividing both of these. So 1/9 row 3 back into row 3. Okay, we can work on these zeros in the upper triangle last if we want. So that's 1 6/5. That's 1 253. 301910. And this one is 2302 over 9. Okay, so that's actually what C is. So we might note over here that C is 2302 over 9. I got that one. Okay, so this one needs to be a 0. So we're going to use this row. So and this one all need to be zeros. Okay, so let's change row 1 minus row 3 back into row 1. Okay, so 3 stays the same. 2 stays the same. And row 1 is changing. It'll change to 1, 1, 0. Negative 25 over 9. Okay. Now this row 2 needs to change. And it'll be 6/5 row 3. Kind of weird with fractions, but definitely doable. Okay. So 1 stays the same. Row 3 stays the same. Okay. And row 2 will now become 0, 1, 0. Okay, after you multiply this. And this is real tricky here. This becomes negative 151 over 30. Okay, so notice I got what Y or what B is. So I'll come back over here and put B equals negative 151 over 30. Now notice the last thing I need to do here is make this a 1. And I'll do that by simply subtracting row 1 minus row 2 back into row 1. or you can just substitute it in and figure it out. Okay, so when I change that, this one stays the same. This one stays the same. And this one becomes 1, 0, 0, 203 over 9. 9D. Okay, so that tells you what A is. So A is 203 over 90. So now I can put all three of those back into the form that they wanted it in. So I have y equals 203 over 90 x squared minus 151 over 30 x plus 2302 over 9. And man, was that fun. Okay. I appreciate you staying with me through that. Here are your suggested problems again with your questions from chapter 7.1 that you need to have done for class. As always, thanks for watching. If you got questions, come see me. This is at THS Mr. Jones signing off.